Good morning. So the topic is about superconductivity and various experimental results, and also about the Wisner effect and the isotope effect. So before going to deep into this subject, let us understand the basic concept what is superconductivity, what is superconductor, and what the Ohm's law will say. Okay, everything. So please watch the previous video to understand the basic introduction of superconductivity. Now, what is superconductivity means? If you have a certain material, suppose let us consider a conductor. Okay. So, if the material resistance suddenly drops to zero when it is cooled at low temperature, is known as superconductivity. Means the electrical resistivity, electrical resistance of any particular material, any conductor or any metal, suddenly its resistance drops to zero. Means suddenly its resistance will tend to zero when it is cooled for a low temperature. It is known as superconductivity. Okay, resistance, the electrical resistance of a particular material suddenly drops to zero when it is cooled below temperature. Okay, it is known as superconductivity phenomenon. So, the material which allow the phenomenon of superconductivity is known as superconductors. So, kindly remember one thing, that any electrical resistance of a particular material will goes to zero. The resistance is suddenly drops to zero when it is cooled below the temperature. Okay, when it is cooled for the below temperature or a lower temperature, when it is cooled at the lower temperatures, then this phenomena is termed as superconductivity. Then the material which allows the phenomena of superconductivity is known as superconductors. So these are the basic definition of superconductivity and superconductors. Okay. Now critical temperature is one of the basic definition in the superconductivity topic. Means critical temperature is represented with the letter Tc, and as well as the critical temperature is also known as transition temperature. Okay. Now a normal metal passes to superconductivity state is known as critical temperature. At certain temperature, the normal metal is going to behave as a superconducting material. The temperature is known as critical temperature or transition temperature. So let us consider a graph between the temperature T and the resistance rho or electrical resistivity rho. Okay, as what I said, the normal metal at certain temperature, the normal metal is going to act as superconductor. Means the conducting material behaves as a superconducting material. What is the conducting material? The material which allows the flow of current. Okay, with small resistance. Even though for a conductor, small resistance will be there at the low temperature. But what is the main phenomenon of superconductor? Superconductor means the material which completely the resistance will be zero when it is cooled below temperatures. Okay, when it is cooled at lower temperatures. Means simply we can say that the conductor still will have, even though there is a flow of current in the conducting material, there will be some resistance. Okay, there will be some resistance. But as we make the superconductors, the resistance will be zero. There is a main difference between the conducting material or conductor or a superconductor. Means let us consider it now between T and rho. So as the temperature is there, if we apply some temperature on a material, the material when it transforms into, when the normal metal transforms into a superconducting material, at that time a particular temperature is known as critical temperature. So it is represented with the letter T. Right? it behaves as, okay, up to certain time it behaves as normal metal. Okay, means it have the non-superconductor. So up to this period it is a superconductor, non-superconducting material. So as we go on increasing the temperature, the resistance will be going to be decreased. So kindly know the relation. As the temperature is increases, okay, the resistance is going to be decreased. Okay, as the resistance is decreased, the flow of current will be infinite. Okay, now at this particular temperature, the material is going to be passed as or act as a superconductor. So these phenomena is known as critical temperature. So critical temperature is nothing but the particular temperature. At particular temperature, the normal metal will be classified into a superconducting material. Okay, normal conducting state to superconducting state. So the temperature is known as critical temperature. Okay, then critical magnetic field. Okay, it is same as the similar to the critical temperature. What is the critical temperature? At particular temperature, the metal is going to act as a superconductor. Now, the critical magnetic field is represented by the letter Hc. H is the magnetic field and the letter C indicates critical. Okay. Now, simply let us plot a graph between the temperature and the magnetic field. Okay. So, as we apply the magnetic field, okay, for a particular metal, what the changes we see, we can note in this graph. The critical magnetic field is nothing but now at the minimum, the critical magnetic field is nothing but the minimum magnetic field which is required to destroy the superconducting state is known as critical magnetic field. Suppose let us consider a superconductor. Okay, if you take the superconductor. So as we apply the magnetic field, okay, as we apply the magnetic field at a particular point of magnetic field, okay, at a particular point of magnetic field, if the superconducting material will change into its normal state, normal material. So that magnetic field is known as critical magnetic field. So simply remember that critical magnetic field is nothing but the minimum magnetic field which destroys the superconductivity nature. Okay, which destroys the superconductivity nature. What is the destroy of the superconducting material? What is the destroy of superconducting state means? The superconductivity state to destroy means the electrical resistivity will be restored. Means the electrical resistance of a material will changes from 0 to infinite. Okay, so that situation is known as, that magnetic field is known as critical magnetic field. Okay, now let us plot a graph between the temperature T and magnetic field. So up to certain temperature Tc and Hc, it acts as a superconducting state. So if we apply magnetic field, greater than the critical magnetic field, okay, greater than the critical magnetic field, then the superconducting material is going to act as a conducting material, right? So this is the entire theory of critical magnetic field. So the formula, mathematical expression for a critical magnetic field is Hc is equal to H naught 1 minus T square by Tc square. So Hc means the critical magnetic field at the temperature Tc. Okay. So it is also a critical magnetic field at temperature T or 0 Kelvin. Okay. Now this is the Critical magnetic field means which destroy the superconducting nature. Means what is the destroy the superconducting nature? Means the resistance, electrical resistance will be increased. As the resistance increases, the conducting state will be decreased. The flow of current will be decreased. So this is the entire theory of superconductivity. Okay, superconductivity nature, superconductors, and critical magnetic field and critical temperature.